Welcome back to Properties of Electricity. This ability and skill to identify the properties of something and the relationships that those properties share with each other, and to use this information in conjunction with deductive reasoning, is a transferable skill and an asset to learning about anything. On a professional level, this skill is invaluable to employers. So I honor your interest in developing this, especially on the subject of electricity. In this class, we use the properties of electricity as a portal or a window to see and understand something that is otherwise invisible. Electricity. Okay, let's dig in. Here's our cast of characters: resistance, volts, and amps. Ohm's law describes how they play together. Let's start with the electrical property of resistance, symboled by the omega sign. Everything in this world has some electrical resistance, but what does that mean? What is electrical resistance? From Wikipedia, electrical resistance is the measure of difficulty to pass an electrical current through a conductor. Conductor is a fancy word for wire. I like to think of resistance as bumps in the road, things that slow us down, obstacles in our path, a drag. Electrical resistance gets in the way or impedes kinetic energy. Static energy and kinetic energy are forms of electricity. We're going to talk more about that in another lesson. The unit of electrical resistance is referred to as an ohm, named after George Ohm, a school teacher who had the opportunity to play with a battery recently invented by Alessandro Volta in the early 1800s. What George figured out from his battery experiments is that the current in amps passing through a wire is equal to the voltage divided by the resistance in the circuit. So once again, the amount of current in amps of an electric circuit equals the circuit voltage in volts divided by the total circuit resistance in ohms. So the relationship of these three properties of electricity can be described as a love triangle. Dilbert electrical engineers and physicists refer to the unit of electric current with the letter I for intensity, but most of us in the real world refer to electric current as amps. You might be asking, how is this valuable to me? Well, if we don't know some of the electrical properties of a circuit, we can use Ohm's law to calculate them. For example, in this circuit, we know we have 12 volts and 4 amps, but we don't know what the circuit resistance is. Using Ohm's law, all we need to do is divide the 12 volts by the 4 amps, and voila, the circuit resistance is 3 ohms. In the second example, we don't know what the circuit voltage is, but we know what the current and resistance is. To find the voltage, we simply multiply the 12 amps by 10 ohms and learn that our circuit voltage is 120 volts. Great work! Ohm's law is an invaluable tool for anyone who wants to work with electricity, and a measure of success is an equally important part of the learning process. So let's pause here for a quick quiz to reinforce the information. Thanks for your hard work, and we'll see you soon.